Hello students, welcome back for our chemistry class, that is from pre-chemistry. The topic of organic chemistry 1, and today the subtopic is hydrocarbons. Now the objective of our lesson today, we have around 4 objectives to meet. One, at the end of this class, you should be able to define saturated and unsaturated organic compounds. 2, you should be able to define the term hydrocarbons. 3, you should be able at the end of this class to define alkanes. And finally, before we stop, you should be able to give the molecular, open structural, and condensed structural formula of alkanes. So those are the 4 major objectives why we are here. So let's go step by step and achieve each one of them as we continue. Now, saturated organic compounds. Saturated organic compounds are organic compounds in which only single covalent bonds are present in their molecules. So in the molecules, we only have single covalent bonds. If you recall last time, the last lesson, we talked about the types of covalent bonding. We said that carbon is unique in that carbon can form 3 types of covalent bonds. Carbon can form 3 types of covalent bond. We talked about carbon-carbon single bond, carbon-carbon double bond. Then we talked about carbon-carbon triple bond. But now we are saying that when you have carbon-carbon single bond, then you have a saturated organic compounds. Saturated. Now, the second thing is to define unsaturated organic compounds. These are organic compounds in which either double bond or triple bond is present in their molecules. So in those compounds, you can either get double bond or a triple bond in their molecules. Such compounds are called unsaturated organic compounds. Unsaturated organic compounds. Yes, so note a saturated solution, we are talking of organic compound, unsaturated organic compound. Now, after understanding the difference, now we can go ahead and look at what we call hydrocarbons. This one is not a new term. This is a term that you met in Form 1, where you learned that in Form 1 that we have certain substance like candle wax. When you burn candle wax, it burns to give carbon dioxide and water only. Now, hydrocarbons are a group of organic compounds containing hydrogen and carbon atoms only. So they are made up of carbon and hydrogen only. Yes, carbon and hydrogen only. Those are what we call hydrocarbons. So, in fact, under organic chemistry 1, we are only dealing with hydrocarbons. We are only going to deal with compounds made up of carbon and hydrogen only. that class of organic compounds. We move to the classes of hydrocarbons. We have three classes of hydrocarbons: alkanes, alkenes, and then alkynes. So we have alkanes, alkenes, and alkynes. So the whole of this chapter talks about three things. It talks about hydrocarbons, but three classes: alkanes, alkenes, and then alkynes. So the first one are alkanes. You need to understand alkanes. Now, alkanes are defined in a very simple way. Because alkanes are made up of carbon and hydrogen only. Because alkanes are made up of carbon and hydrogen only, they qualify to be called hydrocarbons. So we are talking about alkanes. That's one. Then the next question: are they made up of carbon-carbon single bond, or carbon-carbon double bond, or carbon-carbon triple bond? Alkanes are made up of carbon-carbon single bonds. And if they are made up of carbon-carbon single bonds, it means these are saturated organic compounds. So we define alkanes as, alkanes are simply defined as saturated hydrocarbons. Saturated hydrocarbons. That is the simple definition that we normally give alkanes. So they have carbon-carbon single bond, and they are made up of carbon and hydrogen only. Yes, we move ahead. So another thing that we need to know about these compounds that we call alkanes is their general formula. Their general formula, because we are talking about a group of compounds. Alkanes, a group of compounds. Now, alkanes have a general formula. General formula, and their general formula is CnH2n plus 2. Where N is the number of carbon atoms. You can have one carbon atom, you can have another alkane with 2 carbon atoms. There's another one with 3, there's another one with 4 carbon atoms. So N is a whole number and represent the number of carbon atoms in a given molecule of alkane. So if N represents the number of carbon atoms, let us take examples where N is equal to 1, N is equal to 2, N is equal to 3. Let us see. So what about if we have an alkane where N is equal to 1? Meaning where carbon atom, there is only one carbon atom. So where N is equal to 1, and we have this. So we are going to substitute N there, meaning we are going to have C1, then H. 1 times 2 is 2, plus 2 is 4. So where N is equal to 1, you have CH4. We just assume this one. There's no need of writing 1 again. It's like repeating yourself. So simply write CH4. Where N is equal to 2, then we substitute. So we'll have C2 plus. We have hydrogens around many. 2N, meaning 2 times 2, 4. 4 plus 2, 6. So it will be 2 times 2 plus 2. So we'll have C2 H6. That is our second example. And where N is equal to 3, we'll have C3 H2 times 3 plus 2. Then we'll have C3 H8. So these are examples of alkanes. Examples of alkanes. They have a general formula of C2H2N plus 2. For something to qualify to be called an alkane, it means that that particular hydrocarbon must fit this formula. So if you are given something like, C3H6, and then you are asked whether this thing is an alkane, you simply need to check what is the value of N. N here is, because N is the number of carbon atoms. N is 3. So does it fit this formula? No. This one is not an alkane. So alkanes normally have a general formula of CnH2n plus 2. That brings us to the end of the first segment. Let us meet again in the second segment. Thank you.